All right, in this video we're going to talk about thinking and problem solving, problem number 2 in chapter 13 of your textbook. So the problem reads as follows. Sometimes our discussion of marginal cost and marginal revenue unintentionally hides the real issue, the entrepreneur's quest to maximize total profits. Here is information on a firm, and they tell you the following. The demand curve is given by price is equal to 50 minus Q. Fixed cost is equal to 100. And marginal cost is equal to 10. Okay. Now, let me just, let's see. Let me show you the basic idea of what's going on here. Okay, so if we have the demand curve that well, here's the quantity, and here's the price. Let's start at 0 and let's increment by 1 on each unit. A demand curve that is equal to 50 minus quantity going to look something like this, right? It's going to drop by 1 on each transaction. So that if we inserted a graph of this, that would be our demand curve. It's downward sloping like so. Okay, and let's take this out to, I don't know, 50 units or so. Okay. We'll stop there. So there's the demand curve. And then they also tell us that marginal cost is 10 on every single unit. So I'll fill that down. Okay. That is what they're describing, a demand curve that's downward sloping like so, and also has a marginal cost curve that would intersect at a certain point. Now, don't forget, we also need to know our marginal revenue curve. And the marginal revenue curve is always going to be, it starts at the same place as the demand curve, and it drops twice as quickly. So if demand is given by 50 minus Q, 50 in this case minus 0, 50 minus 1, marginal revenue is always going to be 50, starts at the same place, minus 2 times whatever is in the quantity column. Okay, so that, once this goes to 0, let's delete that out. There, that looks better. So here's our marginal revenue curve. So what we're basically doing with those equations, or doing in this problem, is we are looking at equations instead of graphs. But those equations map back into a graph that hopefully would make sense to you, given that you've read chapter 13. Okay. So let's go through this. They ask us to fill out a table. The table looks like this. It's got quantity from 18 to 23, total revenue, total cost, total profit. Remember that total revenue is equal to price times quantity. So there are a couple of ways, you could do this. Okay, you could say, all right, well, I'm going to calculate the price for each unit, which I know to be 50 minus the quantity, right? That's what we're given down here. Price is equal to 50 minus quantity. And if I copy that down, there's the price for each unit. Okay, and so I could say total revenue is equal to the quantity times the price. And there you would see the numbers that I've plugged into the answer key that's online. Okay. There is another way of doing this. If you note that total revenue is equal to price times quantity, and then we also know that price is 50 times Q, I could substitute 50 times Q into this equation for total revenue. Right? I could say total revenue is equal to 50 times Q, sorry, 50 minus Q. That expression times Q. And if you then distributed this Q to the 50 and the Q, what you would find is total revenue is equal to 50Q minus Q squared. Okay? So just as instead of going in 2 steps, first figuring out the price by plugging quantity into the demand curve for each of these transactions, and then multiplying the quantity times the price. The other thing that we could do is we could take this total revenue formula and we could turn it into, this is equal to 50 times the quantity minus the quantity squared. And you'll notice when I copy this down, all the numbers are going to stay the same in that column. Okay, so either way is fine. Plugging quantity into the demand curve to find price, and then multiplying the two, or substituting the right-hand side of the demand curve into the total revenue function, so that it's all total revenue is just an expression of quantity. That'll work fine too. Okay, either way you get the same numbers there. Okay, total cost. What's the total cost going to be? Well, remember the following. Total cost is equal to what? Fixed costs plus variable costs. Now, what are your variable costs in this case? The variable cost of producing a certain number of units is just the sum of all the marginal costs of producing every unit up to that. Okay, so if your marginal cost of producing the first unit is $10 and you produce 1 unit, then your variable costs are $10. Suppose that your suppose that your marginal cost on unit 2 was $8. Well, then your variable cost for producing those 2 units would be the $10 marginal cost on unit 1 plus the $8 marginal cost on unit 2, or $18. If the third unit had a marginal cost of $6, then the variable cost of producing 3 units would be 10 plus 8 plus 6 is 24, and so on. Now, in this problem, we're told that marginal cost is always $10. Every single unit you produce is always going to cost you $10. And so your variable costs in that case are just going to be the number of units you produce times the marginal cost of producing each unit. So we can swap out variable cost for 10 times the quantity of units. Marginal cost times the quantity of units. Okay? And we know we're given what our fixed costs are. They're 100. So our total costs you calculate for each cell will be equal to the $100 fixed cost plus the marginal cost per unit times the quantity of units that we've produced. 280 on the first unit. And if you just copy that formula down, you'll see the total cost for each level of output. Total profit couldn't be simpler. Profit is just total revenue minus total cost. So it's just the number in the C column minus the number in the D column. And there you have it. So it said using that information, calculate the total profit for each of the values in the following table and plot the profit in the figure. Clearly label the amount of maximum profit and the quantity that produces this level of profit. Okay, now you could just make a graph. This is the way I did it. There we go. Right? There's a graph, although that's not particularly attractive. So I like to look at the entire graph. So let's start this at 0 units. And keep going until, there we go. Okay. So total profit, oh, actually, let's trim back. start by looking at everything in both of these columns. And then we'll trim it back a little bit. There we go. So there's total profit. I'm going to clean this up a little bit because I don't want to look at cases with negative profit. So we'll format that axis there and cut off at 0. There we go. And this is more or less what you saw in the answer key. Okay, this is just plotting for every quantity that you could produce. What is the total profit that you get at that quantity? And you can see that this curve maxes out here at $300, and that is at 20 producing 20 units. Part B, if the fixed cost increased from 100 to 200, would that change the shape of this curve at all? Also, would it shift the location of the curve left or right, up or down? How does this explain why you can ignore fixed costs most of the time when thinking about a monopoly's decision-making process? Okay, so this is the total profit given a fixed cost of 100. If we wanted to find an alternative total profit, call that total profit 2, it's just going to be the total profit before minus another $100 in fixed costs. And so you copy that down and now make this a graph of both of these two. And there, once again, you've got a graph that looks like the one that I posted on Blackboard. Here's the original profit function when you had a fixed cost of 100. Here it is when you have fixed costs of 200. Notice that all that's happened is every point on this orange graph or orange curve is $100 below the equivalent point on the blue curve. Okay, so notice that it doesn't matter whether the fixed costs are 100 or 200. You still maximize profit at the same level of output, 20. Okay. In fact, let me change this up a little bit more. Let's say that the fixed costs, I'm going to turn the fixed costs into a variable. So, oops. 100. Okay. So now the numbers in these cells are not just subtracting 100 from the original total profit. They're going to subtract whatever's in this cell up here. So we can see, okay, what would happen if you increased those fixed costs by, let's say, $200. Well, then the profit is going to fall farther, right? Now every point on this orange curve is going to be $200 below the equivalent point on the blue curve. And suppose you went to 250. Well, then it's going to shrink again. 275. Shrinks again. But notice that no matter what I do to those fixed costs, I'm still maximizing profit at the same level of output as I was when my fixed costs were lower. So it doesn't change what I should be doing in terms of how much I should produce. Now, if the fixed costs go to $300, now if I produce that profit maximizing level of output, it turns out I'm just breaking even. Okay, my economic profits would be 0 in that case. And if it went up by even $1 more to 301, now this orange curve is below even $0. And so I'd actually be making a negative profit. You should be able to see that. If you go here, -1. That is the largest number that shows up in this column. Now, once you hit that point where the orange curve, let's format this axis so that we can see more of the orange curve. Once it falls below 0, now is the point where the firm wants to think about just getting out of the market. It's going to want to exit the market as soon as it can get out of its fixed costs. Okay, But as long as the fixed costs are lower than $300, like again, $250, the firm's making positive profit, and it's still going to want to produce that same level of output, 20. So the only thing that fixed costs can do is not change how much a firm wants to produce. It just changes whether the firm wants to be in the market at all or not be in the market at all. Okay, so that is the answer to problem 2 in thinking and problem solving. Thanks for watching, guys, and remember to be flexible, communicate, and stay awesome.